Chris, Eamon, Ivan, I'm so glad to welcome you here. Thanks a lot for coming and bringing such a nice topic here.
Thank you for having us.
You're absolutely welcome. And as I can see, it's quite sunny at your place. Chris, can you please describe how it is over there?
It's nice and cold in the morning. It's winter now in California, so we're having our cold mornings.
Awesome. Awesome. Eamon, what about you?
It's cold all the time. I'm in Appleton, Wisconsin, much of a northern climate, so no snow quite yet, but it'll be there soon.
Awesome. And Ivan, what about your place?
Nice rainy weather, this usual winter weather in Cambridge.
So everyone feels like glad with the outside. So let's move on to our awesome topic and start the talk.
Excellent. Well, first of all, thank you everybody for having us. Very excited to be here to talk about our project, excuse me, I should pronounce the project right, HobbyFarm, Kubernetes-based in-browser training tool. We have quite an agenda today, a large list of items we'd like to get through. We'll start with an introduction to what HobbyFarm is. We'll talk about the history of why we felt we needed to develop something like HobbyFarm, the needs that it captures for our organization. We'll move on then to discussing the design goals of the application. We have various needs that we need to meet for HobbyFarm, and we'll go through those in depth. We'll then have an expose on the technology choices and the architecture for building HobbyFarm. After we've discussed the architecture and the technology choices, Chris, Kim, and I will break down the backend design and the front-end design. This is a web application, an in-browser training tool, of course. Finally, we'll have a demo of HobbyFarm where we will provision a learning environment during this discussion, and then we'll have plenty of time for Q&A. For introductions, let's start there. My name is Eamon Bauman. I am a senior field engineer at SUSE, formerly Rancher Labs. Our acquisition was just completed this week, so now I am, and Chris, Kim as well, are SUSE employees, but formerly of Rancher Labs. Speaking of Chris, this is Chris Kim. He is a software engineer, also, of course, at SUSE. Thank you for waving. So let's talk history. Rancher is a Kubernetes software company, and part of our Kubernetes software marketing was to do what we called Rancher Rodeos. Rancher Rodeos were in-person, pre-coronavirus, in-person half-day seminars. They were typically hosted in conference centers, hotels, meeting areas, all around the world. It was a great way for folks to get introduced to Docker, Kubernetes, Rancher concepts, and Rancher field engineers like myself, and at the time like Chris Kim, were hosting these Rancher Rodeos around the world. We've since transitioned to a virtual format, which has been possible because of HobbyFarm, but this was the groundwork that was laid in order to make HobbyFarm necessary. Part of the reason that HobbyFarm was necessary is because of the technology stack that we originally used for the earlier rodeos. The Rancher Rodeo format was the presentation of a slide deck plus an interactive learning session. So we would go through a long list of slides, an introduction to Docker concepts, to Kubernetes concepts, and then at the end, we would go through an interactive learning session. Again, this was typically hosted at a hotel or conference center, and the interactive learning portion of the rodeo was driven by HashiCorp Vagrant. We would ask attendees to download box images to their computer, start virtual machines, stand up Kubernetes clusters, and interact with these VMs. Now, if you're paying close attention, you may see a problem with this. The problem with this is shown in this graph here, bandwidth. That was a big concern at the Rancher rodeos. Conference Wi-Fi is great for simple access when you need to download email, when you want to check Facebook, when you want to come to a DevOps conference, but it's not so great for large downloads. So for instance, we would have our rodeo attendees download a Ubuntu 16.04 LTS image. That LTS image was 291 megabytes in size. Now, consider that 291 megabytes in size over 30 to 50 users, and all of those 30 to 50 users at once. Provisioning of these VirtualBox images took hours. Absolutely, honestly, took hours. There were other issues that were faced when we were using Vagrant on a client's workstation. A lack of admin rights meant that our attendees may not be able to even install the virtual machines necessary for this rodeo. Firewalls also played a strong role here, where if the user was not able to download these images from the HashiCorp website, or they weren't able to open up the appropriate ports on their computer, there were issues. Zscaler was the biggest, what's the word I'm looking for, culprit, the biggest culprit in going through all these problems. Zscaler created so many issues with downloading VirtualBox images, with starting them, with doing all these different things. So we came together after identifying these issues and tried to figure out some potential solutions. One potential solution was to pre-seed the images onto some sort of laptop that the user would bring, or use smaller images. The idea would be that an attendee to a Rancher rodeo could read the instructions ahead of time and download the images onto their workstation. That would help with the conference Wi-Fi issue, but it doesn't solve for the lack of admin rights. We still would have attendees who lacked administrative rights on their computers and wouldn't be able to perform the actions. We could cloud host the virtual machines, so we could set up instances in AWS or Azure or Google or wherever, but that's largely a manual process. We would still have to go VM by VM and set those up. Of course, there are Terraform scripts and so on available, but it would also not solve the firewall issue. Some users on their laptops may not have outbound TCP port 22, or there could be corporate proxies in the way, forcing their traffic through a corporate destination without allowing that connectivity to the VM. We also looked into something like Katacoda. The issue that we had with Katacoda is that its software runs a magic proxy, in quotations, and this magic proxy does not send a host header, which is required by Rancher software for correct operation. It also has a lack of flexibility, and we desired the ability to customize our images in our to-be-designed system to our needs. We desired to customize the firewall rules and the content, and we lacked that heavier flexibility within the Katacoda platform. With that in mind, then, we needed something new. So what we decided to do was start HobbyFarm. HobbyFarm is an interactive, browser-based, Kubernetes-powered learning tool. There's a lot of words in there. We'll break down what all of those mean. HobbyFarm provides individual virtual machines to users, along with instructions for learning new technologies. Also, and this was critical to what we were doing, HobbyFarm is 100% open source. So you yourselves today can go to github.com/hobbyfarm and see all of the open source work that we've done and the code that we've committed. We had primary and secondary design goals in mind when writing HobbyFarm. The primary design goals were this. It needs to be entirely browser-based. The content we desired to be written as Markdown and then rendered as HTML. We wanted to do this so that we could safely store our learning content in a Git repository in an easy to write format, but yet have it rendered into the browser. We wanted web shells to be able to connect into virtual machines so that users could perform SSH sessions inside their browser without requiring actual SSH connectivity. Even with restrictive firewalls, it is expected that ports TCP 80 and TCP 443 are generally allowed out to the internet. Our experience was that even in restrictive firewall sessions, such as with a Zscaler or Zone Alarm, that those ports were generally available to the internet, and most domains should be allowed. You see most with a little asterisk next to it. This is because in the early days of HobbyFarm, we encountered issues with firewalls still restricting traffic to our new domain. We registered hobbyfarm.io, and for a period of time, I would say the first couple months, some firewalls restricted access to that domain as it was a young domain. The next design goal was automated provisioning of resources. We desired that virtual machines should be provisioned automatically and according to the needs of the event in which they were being used. Speaking of events, we desired to schedule the events ahead of time so that users, administrators could schedule their events ahead of time with a known capacity and have the virtual machine resources prepared and ready prior to the start of the event. We also desired flexibility in infrastructure choices. We wanted the ability to use a public cloud provider such as AWS or Azure or Google Cloud without having to sacrifice flexibility by locking into a particular provider. Our final primary design goal was flexibility in virtual machine choices. We wanted to be able to introduce stateful capabilities, differing host operating systems, differing resources, package installation, anything that you would use to customize the host operating system, we wanted the ability to perform those customizations. Our secondary design goals largely surrounded the admin and front-end interface. The first secondary design goal, which Chris Kim can attest to, quickly became a primary design goal, was our click-to-run functionality. The click-to-run functionality is the ability to click a code block in the browser and have that code executed in the web shell for the user. This quickly became, as you see, a primary design requirement, as our users were attempting to copy and paste the code from their markdown into the terminal and encountering issues while doing so. A secondary design goal number 2 was a full admin interface. This is still currently a work in progress. Most operations are available. A lot of the configuration, however, is still done behind the scenes. So the heavier lifting of setting up environments like cloud providers or new virtual machines is still done behind the scenes today, but active work is being done on the admin interface to make it a fully featured implementation. The third and final secondary design goal was exportable content. We wanted the ability for users to take the content that they had learned with them for viewing later. So we developed an ability to export the markdown content as a PDF, and the users are able to take that information with them after the completion of the Rancher Rodeo, and they can perform the steps that they just learned during the interactive session. I now hand it off to Chris Kim to discuss our technology choices and the back-end design.
All right. Thank you, Eamon. So I'm going to start diving into the back end here of how HobbyFarm actually works. So if we look at our next slide, we'll be able to see that we have a couple of technology choices that we wanted that we made. And so the first is actually going to be around Golang. So Golang is the language we use to write the back end of HobbyFarm. And the reason we chose Go is because HobbyFarm is powered by Kubernetes. And so I'll dive into what that actually means in a little bit here, but we are very, very dependent on Kubernetes. Controllers are actually really critical to the design of HobbyFarm because HobbyFarm essentially is a desired state machine. And so every time we actually create an event or a provision a virtual machine, we have controllers in the background that are reconciling state to get our virtual machine to the desired state. So whether that be something like we want to provision a virtual machine, we need to use that controller to create the various instruction sets so that we can get that virtual machine to be provisioned. The actual provisioning is handled by Terraform. So what we're using is a Terraform controller, and we'll dive into this as well. And this is another Rancher project that was created. But this will actually allow us to essentially provision our virtual machines in any cloud provider because we can use any Terraform provider with it. The front end is a little bit different. It uses Angular and then the Clarity design system. So these are going to be the two frameworks that are used on the front end side, and you will be able to see these in the demo and also in the source code if you want to look at that in a little bit. From a virtual machine technology choice, I kind of already talked about this, but we actually had some very specific requirements for the virtual machines and why we wanted to use virtual machines instead of some other alternative solutions. So if we look at it, every user needed their own segmented space to work with, which means that every user needed to have an independent learning environment where no other user could come and cause them problems. Containers, unfortunately, do not provide enough isolation between users. And what I mean by this is that when a user is using a container, they still, they're not full on systems. And sometimes the learning content we are trying to give requires things like systemd and so forth, which don't really exist in the container realm within a container. The other big problem we actually had was that Rancher does not have a very large internal data center. Rancher is a startup. We have a little bit of a lab environment inside, but we would actually need to use the public cloud when using these actual virtual machines because our data center just didn't have enough capacity for what we needed to provide. We did analyze the idea of using a project like KubeVirt because the idea of using Kubernetes even further from where HobbyFarm uses Kubernetes was appealing. But we found at the time that we were developing HobbyFarm that KubeVirt was not actually fully ready for us to use as a virtual machine platform. Now that we've actually started working on projects like Rancher Harvester or even just the KubeVirt project itself, we can actually look at this again and are potentially talking about using KubeVirt in the future to be able to host our HobbyFarm virtual machines. Instead of directly provisioning our virtual machines, I talked about this earlier, we actually decided to use another Rancher project called the Terraform controller. And the Terraform controller is really just a set of controllers that operate on Kubernetes custom resources and can essentially perform a Terraform apply for you. Even so, HobbyFarm is built to be pluggable with any provisioning tool. And what this means is that if you don't want to use Terraform, you can actually write your own controller and the actual data structures are already set up in place so that when you come through and you define your own virtual machine type or virtual machine provisioning method, you can actually just use your own provisioning tool. We had another software engineer at Rancher who went through and designed an EC2 controller that directly provisions against EC2 instead of using the Terraform provider for EC2, and you can see that in our repositories. The actual architecture of the entire system of HobbyFarm can be boiled down and looks quite simple here. If we look at this architecture diagram, we can see that the client front end and the admin front end are two separate components, and those are primarily what Eamon was able to work on because Eamon was built those components. The center circle is actually circling what we call Gargantua, and Gargantua is our Golang monolith. It has multiple components in it, but primarily it serves to be the API server, the shell server, and has the various controllers to operate against the Kubernetes cluster. You can see in the bottom right that we have the Kubernetes cluster defined as well in this architecture diagram because Kubernetes is very, very important to the actual cluster. At the bottom, we have the Terraform controller, and the Terraform controller is still a Rancher project, but it runs independently of HobbyFarm and is itself interacting with the Kubernetes cluster. So we with HobbyFarm don't ever actually directly interact with the Terraform controller, but we create the various custom resources that the Terraform controller requires in order to be able to provision our virtual machines. So Gargantua is the big component I really want to talk about because it is actually it is probably where we wrote the most code other than the front end. The name is Gargantua is a Golang monolith on the back end, and the name is actually from the movie Interstellar. So if you've ever watched Interstellar, you would have seen the Gargantua reference or the black hole inside of the movie, and we kind of jokingly called it Gargantua because it was a giant Golang monolith, and so we kind of figured that would be a funny name. The backend design, so Gargantua itself is actually quite simple. So we use a couple of components here. We use the Kubernetes client Go. And if you're familiar with interacting with a Kubernetes cluster from a Go perspective, you've probably come across client Go. We heavily utilize client Go for things like watching and for resource manipulation. We are using Kubernetes controllers. And really what we mean by Kubernetes controllers is really controllers written and using client Go to interact with the Kubernetes cluster. Gargantua serves a JSON API and is actually and that's actually how the front end, so the admin front end and the user front end are talking to Gargantua on the back end. And we're using Java Web Tokens or JavaScript Web Tokens so that we can provide authentication between the front end and the back end to make sure that users are who they are. And this is actually an area that Eamon primarily worked on. But that is how we do our authentication from the perspective of authenticating the API. I've already mentioned this already, but we've used the Terraform controller. And the actual, one of the big things that we also did was a WebSocket shell. And so what the WebSocket shell is it allows the user to establish a fully blown SSH session to their virtual machine, but from within their web browser. So they don't need to fire up a terminal or use SSH commands or anything like that. We do the magic for them. And this is all tunneled over the secure socket 443. So that's what Eamon was alluding to earlier in the design choices and the problems we encountered, which is that we would be working on certain sites and we would find that 22 outbound would be blocked, and we needed to find a way around that. HobbyFarm, so this is the data storage component is actually where Kubernetes is the most prevalent. We are primarily storing we're storing all of our metadata in our Kubernetes cluster as custom resources. And if you're familiar with Kubernetes, custom resources are extremely powerful because you can basically store any arbitrary data inside of the API server for Kubernetes. Both the API server and the shell server are interacting with that Kubernetes API using client Go to be able to retrieve and actually store and manipulate the data. There are also a set of controllers, and I'll talk about this in a little bit here and give you an example of one of them, that are constantly watching the Kubernetes API through the client Go, and they act on the changes to the various objects. So they retrieve the object, they observe the object, they do whatever they need to the object, and then store the new version. These controllers are actually a majority of the magic behind HobbyFarm itself. So a big question we get a lot with HobbyFarm is, why did we choose Kubernetes? And so Kubernetes is great. Kubernetes actually has a framework for controllers. And so these controllers are actually being utilized by HobbyFarm for constant reconciliation. Excuse me. Using Client Go, we provide a great, or Client Go actually provides a great framework for writing these reactive controllers. There exist other ones out there, and Rancher has a few projects, like Terraform Controller actually uses one called Wrangler, but we decided to go down the path of just using straight Client Go and building our own controllers themselves. And really, if you actually look at the type of things we're doing with HobbyFarm, Kubernetes controllers are a natural fit for this type of work. The second reason why we chose Kubernetes, or second major reason, is because Rancher is a Kubernetes company. If you've heard of Rancher Labs before, you've probably heard of our flagship product, Rancher, which is a multi-clustered Kubernetes management tool. And so our entire business, our entire product line is built around Kubernetes. So it only made sense that we would try to use Kubernetes more. And that's really our dog fooding that we brought in. And it really gave a good experience to all of our engineers who worked on this project so that they could actually learn the inner workings of Kubernetes and how to actually manipulate Kubernetes to do what they want it to do. I've already talked about this in a little bit, but I want to expand on it further. We have a JSON API that actually interacts with the front end. And so Gargantua is serving a JSON formatted REST API to the front end. And what this really means is just that the Gargantua or the API server itself is just serving the data it needs to and parsing it and using the Golang JSON formatters so that it can actually format and basically parse our various data from the front end, whether a user sends data or not. Every object that is served from our REST API actually has a corresponding Kubernetes custom resource. But not every HobbyFarm custom resource actually is served via the REST API. And this is because we have a lot of internal only objects that we use for metadata reconciliation and so forth that don't need to be served to the users. So the API is not one-to-one with the objects. If we actually look at the software entities that we have around HobbyFarm, we get this giant web, and the web is actually quite overwhelming when you look at it at first. But most of the names of the objects actually, they sort of they self-explain or they explain themselves. And so if we start over here at the top left, we can see that we actually have most of the front end side. So the user is represented as a custom resource, and access code is a method that the user uses to get access to the various scenarios that they want to be able to go through and actually learn on, because we have multiple scenarios and not every user should have access to every scenario, or we might have custom ones for custom customers or custom users. And that is actually very important for us to be able to restrict that. So we built this access code concept. The scenario is a representation of the actual learning material that our user is going to go through. And the scenario session, or what has actually been renamed to session, is a instance of that scenario content being served. And so that actually is what ties us to our virtual machines and so forth. And if you actually follow the scenario session, you can see that we have virtual machines, virtual machine claims. Those virtual machines and so forth live in environments. And I could keep going on and on and on about this, but honestly, this is quite confusing. So I can break it down a little bit. If we go and we look at our software entities, we can actually track them. So from the virtual machine and environment perspective, we have these custom resources. So the environment is the actual cloud or wherever the virtual machines live. So that would be something like an EC2 cloud, or could be a VMware cluster, even a KubeVirt cluster or so forth. The virtual machine template is actually a template for what we use to provision the virtual machine. And the reason we needed this virtual machine template is actually to provide abstraction, because the scenario requests a certain type of VM, but that certain type of VM would actually mean different things in different clouds, right? So a T2 medium in EC2 doesn't have an equivalent in GCP or Azure. And so the virtual machine template actually provides the abstraction so that we can call the virtual machine something that we know, and our controller logic in the backend will actually go through and translate that using the virtual machine template to whatever that environment needs on its side. The virtual machine and the virtual machine claim, which are the two objects here, these are simply representation objects. The virtual machine is actually representing a real virtual machine. The virtual machine claim is how we bind a virtual machine to a user without having to necessarily modify the virtual machine object itself, which will make sense when we look at the controllers. A virtual machine set is actually a predefined number of identical virtual machines we provision. Eamon sort of talked about it earlier with the scheduled event, and we'll actually go through a scheduled event provisioning process. But when we actually look at this, the virtual machine set is actually used, and we say, for example, we would want 20 T2 medium virtual machines in EC2. We would use a virtual machine set to sort of define that we want 20 identical virtual machines. And we have a controller in the background that when the old virtual machines are retired, so a user is done using them, the virtual machine set controller will actually go and reconcile that and add a new virtual machine in its place to keep a desired quantity at 20, for example. We also introduced a new feature called dynamic bind. And the reason why we wanted to introduce dynamic bind and what this is actually around the concept of being able to dynamically create virtual machines on the fly so that we didn't have to go through and always create 20 virtual machines and burn a bunch of money in AWS. So dynamic bind request and a dynamic bind configuration are the two objects that correspond to the actual virtual machines when we provision them on the backend. And the important thing to note here is that the dynamic bind request and the dynamic bind configuration are abstractions because, once again, because we're working with any cloud, we needed to be able to define a set or type of VM that we wanted. And sometimes we actually had certain nuances with the various clouds. The other reason why we would primarily use dynamic bind is what in an event, a pre-scheduled event that we knew a rough number of users we would have, we could pre-provision a certain number of virtual machines with the intentions of having enough for the users that show up. And in the event that sometimes we have an event that has too many users or more than we were expecting, dynamic bind would actually be able to fill in the gap and provision additional virtual machines for our users so that we were not having to go into the admin interface and figure out how to provision additional virtual machines. So we basically designed HobbyFarm so that it was scalable, so that any user would be able to end up actually being able to attend or use the content regardless of how many we had planned for. On the content and access side, we have various software entities. And so we have the concept of scenario, and I've talked about this a little bit already, but a scenario is really just the content that is served to a user so that when they walk through their scenario, they are able to actually get the content that they need. And the scenario also defines the type of virtual machine they need. We have the concept of course, and the course is actually going to be a collection or a set of scenarios. And this is going to be in the sense that, or for reasons that, let's say you have a very complex technology and you would like users to be able to go through multiple scenarios to learn this one technology, you could create a course for this technology that has the various scenarios in it. And that would allow the users to be able to walk through many different scenarios without having to use many access codes, which is actually the next entity here. The access code is actually what the user enters to be able to get access to scenarios. And also the access code has bind magic on the back end that allows the user access to specific virtual machines. And this is actually quite important as well. That functionality is quite important because in some cases, the virtual machine sets, you would, if you had multiple HobbyFarm scheduled events at once, you would not want users using virtual machines that are correlated to a scheduled event that was going to expire before they were done with their work, because otherwise all of their work would just disappear on the virtual machine that they were using, which was not ideal. The scheduled event we've mentioned a few times, that is actually how we say we need 20 virtual machines and also these scenarios or these courses at this time. And so the scheduled event is quite important. It's one of the fundamental building blocks behind HobbyFarm itself. Finally, we actually have the user, and the user is going to be the actual entity object that stores our user. We are decrypting the passwords, so we are storing those in the API, or we're storing all of the user metadata, so that's email, name, and password, and so forth. And we also actually are storing the access codes alongside the user object. So we manipulate the user object when the user adds and removes an access code. But this is actually proven to be quite scalable because as users we're basically using Kubernetes as a database, the users can just be stored inside of Kubernetes as if you were storing them inside of a database. So I kind of wanted to dive into the basic Kubernetes controller architecture because this is a fundamental part of HobbyFarm itself. If you're not already familiar with this, this is sort of how this works. So a controller in Kubernetes, or a basic controller, has two distinctive loops. And I put loops in quotation marks because you can have multiple instances of the loops. And I talk about that in a little bit here. The basic controller architecture of Gargantua is very similar to the basic Kubernetes controller architecture. And actually what happens is the controller itself, which is really just a loop or a couple of loops, performs a Kubernetes API watch for objects that the controller operates on. So for example, we would say that, the user controller needs to sit around and watch for user objects being changed. And so it opens up an API watch against the Kubernetes API and is looking for those user objects and when they change and so forth. When a change is seen, the object name and metadata are actually queued into a work queue. And so really all this is just taking and seeing, and the controller says from the first loop, hey, this user object has changed, and it pushes it onto our work queue for operation on by this second loop. And this is the second loop. So the controller in another loop is constantly popping objects off the work queue, and it will actually block and wait for a new object in the work queue if there are no objects on the work queue. When it pops the object off the work queue, it is actually going to operate on the object. So for example, let's say that we're using that user object again, and we want to be able to check and see that access code causes a certain change to the user object. Well, when the user modifies that user object through our Gargantua API server, really what that's doing behind the scenes is just updating the user object and storing that in Kubernetes. Our controller can come along, see that the user object is changed, pop that object off the queue once it's been added because of the watcher, and actually then manipulate and do whatever it needs to for this object. Now, keep in mind what I mentioned earlier, which is that you can store pretty much any data in a custom resource. Whether you should do this or not is a completely different discussion, but you can do it, which is what we're doing in HobbyFarm. This actually makes the Kubernetes API and client Go very, very powerful, especially when you're trying to build desired state machines and so forth, and also when you work at Rancher and are primarily a Kubernetes engineer. Note that there actually can be many loops watching the same work queue. And so this is actually quite important to note here, because if you want to add concurrency to your controller, you just have to make sure that you're actually exclusive on what objects you're manipulating outside of it, so you don't end up with race conditions. But you are able to spin up multiple Go functions so that you can watch the same work queue, because it is guaranteed to be it's guaranteed to only serve that object one at a time. So we have another Gargantua controller example that we can actually look at here. So a scheduled event is what I kind of wanted to dive into. A scheduled event, the Gargantua controller that we wrote essentially will read in that list of scheduled events. It determines if an action is required. And so there are two different sorts of code paths that will happen based on the scheduled event. And so the first is going to be with a brand new event. The second is going to be when you have a start or end time pass. And so when a brand new event is created, the event may not necessarily be now. It may be in the future. And when that new event is created, the Gargantua controller will see it. It will add it to the queue because the object itself has changed. And it kind of does a no-op. It doesn't really do any actions on that event. If a start or end time is passed, we know we actually need to do things. And so if an action is required, we can reconcile to the desired state. And this means we can create the access code that we talked about earlier, which is what actually allows the users to be able to get access to the various scenarios or courses. We can create our virtual machine set, so we can pre-provision our virtual machines when the event is ready to start. And that is going to, in turn, actually trigger our virtual machine provisioning. We do have the virtual machine concept here. So the virtual machines are a type of object we're storing. It's a custom resource, and I wanted to dive into this because it does cause confusion sometimes. So virtual machine metadata is stored in the HobbyFarm or Kubernetes API. And this is very important to note. This is only metadata for the virtual machine. This means that we actually are storing the host name, the public IP, the internal IP, the username that is required, the operating system, that type of metadata, but nothing for the actual virtual machine itself runs within HobbyFarm. It's only a representation of the virtual machine in the real world. The design is supposed to be agnostic. It's designed to be flexible because we wanted to allow any type of virtual machine. We've already talked about this earlier, so that's going to be EC2, Azure, VMware, KubeVirt, etc. Any sort of virtual machine. In fact, you could even technically do libvirt on your desktop, and if you populated the virtual machine metadata object and you told it that it is a custom virtual machine, HobbyFarm would actually bind that to you if you were trying to do any local testing. And we've already talked, provisioning is handled outside of HobbyFarm, and the data structures to represent the desired VM use an actual provisioning tool. So that's going to be Terraform controller, and that's going to be our Terraform controller integration. Now, I want to go into Terraform controller really quickly here because this is also a fundamental part of HobbyFarm, but is not actually part of the HobbyFarm project itself. It's another Rancher project. It's a pit cage powered Golang tool, very similar to HobbyFarm, but not necessarily as big as Gargantua is because it does not have an API server. What it more or less does, if you take it and simplify it, is it does Terraform apply based on the custom resource definition you create. And so this was actually originally a project built to serve as the Rancher 2 general purpose virtual machine provisioner. So if you're familiar with Rancher and you've used Rancher before to provision virtual machines or instances inside of EC2, for example, we were going to look at replacing our Docker machine or Rancher machine integration with our Terraform controller. And HobbyFarm ended up serving as a good benchmarking tool to actually put Terraform controller through its paces. We didn't end up actually going down the path of putting Terraform controller inside of Rancher, but the project still exists because of HobbyFarm, and you can still look at the source code. It's all available today, and we are still actively accepting PRs and maintaining it. Rancher Terraform controller actually uses the Rancher Wrangler framework for controller management. And so I kind of alluded to this earlier, talked about this earlier. The Rancher Wrangler framework is built on top of Client Go and provides a lot of boilerplate code or boilerplate generation code so that you don't have to go through the process of repeating yourself, right? So it actually allows for essentially a kind of a dry mentality. This is a little bit different from HobbyFarm because like I said, we're using straight Client Go. We don't have the abstraction layer, but the actual ideas are very similar. And if you ever wanted to get into Kubernetes controllers, you could actually look at both projects and more or less figure out how to write an effective controller. Now, the last component that we have here is going to be the shell server. And so the shell server is the last big component of Gargantua and is primarily something that Eamon actually wrote, and it's his genius work on the back end. But what more or less it does, it takes a WebSocket connection from the user-facing front end, establishes an SSH connection to the user's desired virtual machine, and acts as a piece of middleware to actually handle incoming WebSocket messages and relay them to the open TTY. And behind the scenes, it's actually using an IO pipe, which is how we do the magic of handling our incoming and outgoing messages. But more or less, what's actually happening behind the scenes here is really that a WebSocket connection comes in, and Gargantua then establishes a real SSH session to the virtual machine, regardless of where it lives, and then allows access to that. One of the other big things we actually implemented with the shell server in our architecture with Gargantua is the ability for us to be able to actually deploy independent shell servers at on various clouds or in various regions so that we can help eliminate latency for SSH sessions, because sometimes we would have virtual machines that live inside of EC2 and US West 2, but then other times we would have virtual machines in APAC, and there was no reason to be using a shell server that lived in US West 2 if the users were in APAC in the first place. So that was something that we ended up doing. At this point, I would like to turn it back over to Eamon because he is going to dive into the front end design here and can give you a lot more perspective there.
Thanks, Chris. Excellent. So the front end design components, we started with Angular as our primary design and framework tool for the front end. I implemented a few different libraries into Angular. Auth0 publishes an excellent JWT plugin, so we're using that for our authentication. We make use of the Clarity Design Framework, originally released by VMware. It is an excellent design framework, highly opinionated, easily manageable, and I'll get into those details in a moment. We themed the Clarity Design Framework for HobbyFarm, so we have a custom look and feel while still having the ease of use of the various Clarity components. We implemented NGX Markdown, which is an Angular plugin for Markdown rendering. We did some custom integration with this Markdown renderer, which I'll discuss in a few moments. Xterm.js is an excellent JavaScript package that allows for the creation of web terminals. And this is the front-end technology that powers the web terminal session and hooks up to the shell server that Chris just finished discussing. We have hacky dynamic HTML insertion. This is kind of my favorite bullet point on here. Dynamic HTML is covered in a couple of slides from now, but suffice it to say that Angular does not like dynamic HTML. It prefers static templates, so there was a little bit of workaround needed to make that work. Finally, the front end integrates that click-to-run functionality that we discussed earlier as a secondary design goal for the overall of HobbyFarm. So Angular plus the Clarity design framework. These two components work hand in hand extremely well. I myself, while I developed the front end and the admin interface, am not a great wrangler of CSS. I am not a design expert. I am conversational in HTML, JavaScript, TypeScript, but I'm not a fantastic designer by any means. Because of that, I did not want to be hampered by learning and designing an entire front end. I probably could have made something a little slicker had I spent the time developing all of my own custom components, my own UI framework, things like that, but we wanted to move at a velocity that spending that time would not permit. We still wanted to have a nice looking UI and have it be an attractive looking UI without having to spend all that time designing. So the Clarity design framework made this possible and in fact made it trivial. The Clarity design framework is very opinionated. It is built in Angular from the ground up, which means the interactivity that I required for the terminal and for data access and for various components played nicely from out of the box with the Clarity framework. It also looks really nice with very little effort. Unskinned or unthemed VMware Clarity is a beautiful framework. We themed it obviously to fit with our HobbyFarm design goals, but if you were to use it out of the box, it looks very nice. The in-browser terminal was the first design challenge, let's say, the first design challenge. We developed this in-browser terminal, and how it works is according to a user's virtual machine claim, which Chris just discussed, one or more tabs are created on the page. As you can see in this photo here, the screenshot, I have two tabs, Cluster 01 and Rancher 01. Each of these corresponds to a virtual machine that has been assigned to the user. That virtual machine claim, which again represents the connection between the virtual machines and the user, tells me in the front end how many of these tabs to create. Each of these tabs contains an xterm.js instance. That xterm.js instance is contained within an Angular component that comprises the entire tab itself. Each of those tabs, that Angular component, calls the shell server and hooks up a WebSocket to the xterm.js instance. The xterm library was nice enough to make this easy, so all I need to do in Angular is establish an outbound WebSocket connection to our shell server and then pipe that into the xterm.js instance. A user gets a real terminal in their browser. It is not an emulation. They get a direct input-output, which is via that shell piping, from their virtual machines. So all of the expected control operators work. I can execute Control-C, Control-T, Control-V, pick your favorite letter. All of those control operators work from within the browser because the user is experiencing a real terminal. Markdown rendering was the next bit that we had to concern ourselves with. We needed the ability to insert variables into the rendered markdown. The ngx-markdown library made it simple to take static markdown content and render it onto a page. That was trivial. What we needed to do, however, was insert dynamic variables into the rendered markdown. And those variable values would not be known until runtime. This was going to be data incorporated from the virtual machine, such as public IP, hostname, and as you can see in this screenshot on the right-hand side here, the address and internal address in that YAML block, those are inserted and interpolated variables based on the public and private IP address of the virtual machine while the user was walking through their scenario. This is contained in one of those click to run blocks, so the user simply needs to click and have that YAML file generated inside one of their virtual machines. The NGX Markdown library has an excellent custom renderer that we leveraged for this functionality. The custom function you can supply allows handling of the rendering of the Markdown code blocks. There's a specific hook for custom Markdown rendering for code blocks in Markdown. This custom function we created looks for a little special VM info variable code where X in this example is a VM and Y is a property on that virtual machine. So we're looking for $ open curly brace VM info because we want to only get information from a VM. X is the VM name, Y is a property on the VM. An example of this would be the VM info block. Machine 01 would be the name of the VM, and then the private IP of that virtual machine. So in this example, that variable block would be replaced with 172.16.34.55 if that was the private IP address of the VM. This is sourced from a VM object that is contained, this is sourced from a VM object obtained via API calls. So the Angular component calls the Gargantua API to obtain the VM object for that user. That VM object has all of the metadata information necessary to render the markdown. The next important component was click to run. The example of click to run you can see there, this is from one of our scenarios for the Rancher Rodeo where you can generate an SSH key pair. The click to run functionality provides the ability for a user to click on a code block and insert that into the terminal. It leverages the same NGX Markdown hook as the variable rendering. So I'm tying into that code rendering hook within the NGX Markdown library. The way it does it is a little different. In this function, we're looking for a Markdown code block, and I am abusing the language specification for a Markdown code block. If you're familiar with Markdown code blocks, they use 3 tick symbols and then a statement of what the syntax highlighting should be for the code block. So for instance, you could do JavaScript, Bash, SQL, Golang, whatever, and Markdown would theoretically syntax highlight that code block according to the language specified. We abuse that by placing in the CTR colon and then the name of a virtual machine. So CTR stands for click to run and then the name of a virtual machine. Any code in that block that contains the CTR designation becomes the code that will run inside the associated terminal. So if you click to run on that block in the upper right, it will join to Rancher 01 and insert all of that text. I spoke earlier in 2 previous slides about the in-browser terminal being its own Angular component. Each terminal component in Angular subscribes to an observable of CTR messages. What happens then is when the user clicks on a code block, the action of them clicking on that code block submits a CTR message into this pipeline. The various terminal components receive that CTR message, and that message is formatted according to the name of the virtual machine and the code that's going to be executed. If the name of the virtual machine matches that terminal's name, then that terminal receives the message and puts the code into the SSH session. Finally, we needed dynamic HTML rendering inside the browser. Angular does not like dynamic HTML. It is expecting that components and their associated templates will be static. You can obviously do two-way data binding to fill in various bits of the template, but it is expected that the overall template itself will be static content. You can substitute components themselves dynamically, so if I wanted to swap in component A and component B, that's simple, but the content of the component, the template itself, is not easily dynamically substituted. HobbyFarm's Markdown must be dynamic HTML. We obviously cannot generate an Angular component for every step in a scenario. We wish to store all this in the backend. I can't constantly write components. And we can't just string insert the Markdown onto the page. We need that Markdown when it is rendered through NGX Markdown to yield HTML tags such as H1, P, tables, anything. So we need that HTML content to be inserted to the page. HobbyFarm introduced a dynamic HTML component that takes the rendered HTML from NGX Markdown, sanitizes it, and once it's sanitized, we set it as the inner HTML of the containing Angular object. So for example, this dynamic HTML component, we bind to the content input on that component, and the value of that content input is the HTML that's been rendered from NGX Markdown. That dynamic HTML component then sanitizes the input HTML, and all of the child components are entered underneath that dynamic HTML block. So the P tags, span tags, code tags, H1 get inserted as child components of the dynamic HTML block. There are a few problems that we faced while developing HobbyFarm. The first is that Terraform is not always reliable. So one of the challenges we faced here was that Terraform runs could potentially fail when we were executing them. Chris, did you have more context to add to the Terraform bullet point here?
No, I just, the Terraform runs sometimes fail, or we would see that objects or our EC2 instances would not be terminated even though Terraform would report that they were terminated. So the AWS API was not consistent.
Yep. In HobbyFarm, there's abstraction upon abstraction upon abstraction. And the biggest challenge here was just keeping a mental flow of all the different things we were writing within HobbyFarm. Chris mentioned this heavily in his slide portion of this presentation, but we have to abstract out various cloud providers. We have to abstract out the concept of virtual machines. We have to abstract out the provisioning of those virtual machines. And all of those things are done in order to provide flexibility within HobbyFarm, but they require a deep knowledge of how the interactions occur between these abstractions in order to provide a concrete working example, which is a fully provisioned VM and content rendered in the browser. The Kubernetes API is not fast. It is slow, and that's okay when you're using it for regular Kubernetes interactions. But we discovered that when we use the Kubernetes API as a backend for a web application, there were some concerns about API access speed. One of the concerns in particular that we had was rate limiting that was introduced by the Kubernetes API. The Kubernetes API by default allows a certain number of queries per second, plus a burstable amount of those queries over a period of minutes or seconds. We needed to adjust that bursting capability and the queries per second in order for our heavier workloads, let's say hundreds of users, to not bring down the cluster, or more importantly, make their access so slow that HobbyFarm would completely stop working. We tried and are looking at still solving this issue with K3s plus MySQL. The benefit here is that K3s is a slimmed down distribution of Kubernetes from us here at Rancher Labs. What's important is that K3s contains what we call KINE, K-I-N-E. It stands for KINE is not etcd. It's a recursive acronym. It is a shim between the Kubernetes API and etcd, which allows you to switch out etcd as being the backing data store and substitute something like MySQL or Postgres or SQL Server. KINE acts as the shim layer here, so any Kubernetes API calls hit that shim layer, get translated from etcd into SQL, and then occur into the SQL database. The Kubernetes API, though, was still not designed to be used for a traditional two-tier web application, so it's still kind of a hack on a hack. We're looking at using an embedded K3s server for the sole purpose of HobbyFarm data storage. That's part of the conversations we're having on the next generation of HobbyFarm and what its architecture will look like. Another challenge was users clicking instructions too many times. So let's say that a user has a click to run code block. If that code block is not idempotent, the user may run that command too many times and get their virtual machine into a complicated state because the command is not meant to run more than once. We're looking at introducing functionality to limit the number of times a user may click on a click to run box so that they don't run into that issue of their own creation. The other problem we faced is user proxies, where users may not have the ability to access HobbyFarm because of corporate proxies, or the ability for the WebSocket shell to open because it's expected that their browser will send all of its traffic through a proxy. With that in mind, it's time for the demo. And I've seen in the question and answer section that people are excited for the demo, so let me break out of our presentation here. What I'm going to do is take everyone to our HobbyFarm administration interface. I'll log out here first, and this is what the admin interface currently looks like here at Rancher. What we're going to do during this demo is provision virtual machines through a scheduled event, and then I'll take you through the front end of HobbyFarm and walk you through what it looks like to use a scenario and interact with the web shells. This is being done as though I'm a field engineer at Rancher and I'm going to host a rodeo. So the first thing I need to do is supply my credentials and log in. When I log in, we come to the admin interface here, and you can see there's some placeholder text as we're a little cheeky when we're not quite finishing out our projects. What we'll need to do is click on the scheduled events section here in order to provision a new scheduled event. When I click New Scheduled Event, the browser walks me through creating the scheduled event object. We'll provide a name, so we'll go dev oops 2020. We'll provide a description. We'll just put dev oops 2020 as well. Ooh, if I can learn to type. And then same thing for the access code. So you can see here, this will be the access code that's created, and we will provide this to our end users to allow them the ability to log into HobbyFarm and access their content. The restricted bind option here prevents users from reserving virtual machine resources that are not associated with this scheduled event. The benefit is that if other folks in HobbyFarm, other administrators, let's say, provision virtual machines for their events or for other usage, setting this restricted bind value prevents our users from using those other virtual machine resources. Sometimes this isn't desirable. For instance, if you want to have a pool of general purpose VMs available at any time, you may wish to turn that off so that the users can take advantage. We will click Next, and we will schedule a start and end time for our scheduled event. We'll start it today. It's 11 a.m. here in Appleton, Wisconsin, and we'll end it an hour from now at 12 p.m. Chris talked about the courses. This is a grouping of scenarios. You have the option in a scheduled event to set up courses or multiple scenarios, and that's what we'll do here. We'll pick a scenario from our list. One of the scenarios is what we call Rancher Rodeo XI. That's our version. So this is Rancher Rodeo 11, and it is the remote edition of the Rancher Rodeo content. One of the coolest features that the admin interface has is the ability to determine the scheduling capacity of an environment within HobbyFarm. We have several different environments set up. As you can see, I've got them running in AWS US East 1 and US East 2. And the sections you see here with these green labels, these are the different virtual machine templates that we have set up for these environments. What's happened here between me clicking Next and this page displaying is we've submitted an API request to HobbyFarm to determine the scheduling capacity for the period of time we wish to schedule. That is, I have requested of HobbyFarm how many VMs of various type will be available between the hours of 11 a.m. and 12 p.m. today that will satisfy the number of VMs required for my scenario. So we submit all of that information, and HobbyFarm makes a capacity and scheduling decision to determine how many VMs are available. In this case, I'll use US East 2 because you can see I've got hundreds or 500s of VMs available here. When I click Next, I can define either in simple or advanced mode the number of VMs that are going to be needed for my scenario. We'll use simple mode here, and we'll provision, let's say, for 3 total users. When I click Next, we see the summation of all my options and finish. The page refreshes, and you see that our DevOps 2020 scheduled event has gotten created there. If I refresh the page, we see it has gone into in progress status. This means that HobbyFarm or Gargantua has recognized that the start date has already passed, and so the virtual machines are being provisioned. To illustrate this, I can bring up the terminal and execute kubectl get pods. When I do that, you'll see here that there are these pods running here, job dash and then a random ID. These are the Terraform jobs executing in the Kubernetes cluster to provision the virtual machines that we have just requested. You'll see there are 6 of these pods running, and that's because we are provisioning 2 virtual machines per user, and I requested capacity for 3 users. We'll wait for those to be completed, and it seems that they're terminating right now, so this means we have virtual machines ready for ourselves to use. We'll close out of this terminal here, and we'll open another browser tab and go to Learn. Learn is the domain name for the user-facing front end of HobbyFarm. We'll go to the Register tab to create a new user account, and I'll just put in eamondevoops@rancher.com. It only needs to be a valid email. We're not actually sending anything to it. And we'll put in our DevOps 2020 access code. We'll substitute a password here and click Register. The action of clicking Register has created our user account, and as you see, we move to the Login tab. When I log in now to HobbyFarm, I am requested to select a scenario. The access code directly ties my ability to access a set of scenarios to the list that shows up here in the browser. So you can see this is our Rancher Rodeo 11 remote, and I can start that scenario. When I click Start Scenario, the web app sends a request to Gargantua to receive an allocation of virtual machines. It is creating the VM claim that Chris talked about earlier. With that VM claim created, another reconciliation or Kubernetes controller runs to satisfy that VM claim or that request for virtual machines. As you can see, that VM claim has been requested here and satisfied, and I have virtual machines ready for me to use. When I click Begin Scenario, HobbyFarm takes me to my learning environment, and I can click between my different SSH tabs here to interact with my virtual machines. So here's my Ubuntu 16.04 LTS instance. I can run top and see the various processes that are running. I can Control-C to exit that. I can switch between Rancher and Cluster 01. When I click Next, I can go through the content in this scenario. And let's say I want to use this click to run box to generate that SSH key pair. You'll notice click to run runs on Rancher 01. So when I click it, the interface is smart enough to switch my tab to Rancher 01, insert, and execute that code. There are various buttons along the top here that we've implemented. The Finish button is the ability for a user to completely tear down their virtual machine resources, at which point HobbyFarm will reclaim those resources and provision new ones. It's sort of a desired amount of VMs, so that if the desired amount of VMs is less than what is current, we'll create new virtual machines. You also have the ability to close the scenario and resume it at a later time, as well as pause the scenario. The reason for scenario pausing is that there are situations in which virtual machines will be reclaimed after a period of time. In order to prevent that reclaiming process, you can pause the scenario. This is useful for situations in which you want to take a bathroom break or get lunch or dinner or whatever and resume the scenario when you come back. The user will go through all their steps here and complete actions in the scenario. There's the example of the interpolated variables inside the code block, and I can click to run and generate that YAML manifest there. At the end or the completion of all of the user's learning, they click finish. Their virtual machines are torn down and they're brought back to the HobbyFarm landing page. And if they have more scenarios to go through, they're welcome to continue there. That's the completion of the demo, very brief, of HobbyFarm. I see we do have a few minutes left over for Q&A segments, so happy to entertain any questions, comments, anything like that. Chris, if you have any final comments.
No comments from me. Hope everyone enjoyed the presentation and the demo.
Thank you. It was brilliant. I don't see any questions from the chat, so please provide any questions. I will ask them. Though I prepared a list of my questions for you, so we have a lot of stuff to discuss actually. And the first question is about the use case. I mean, you have covered a lot of low-level examples, like you are able to SSH to new virtual machines. And so I assume that we are able to make any educational stuff, low-level administration, educational classes, or similar stuff. But this is my assumption. What is your main use case for your system? How do you see that?
We see HobbyFarm's main use case as being used for learning cloud-native technologies, things that fit maybe in like the CNCF landscape. Certainly at Rancher Labs, we make heavy use of it for our rodeos. It fits very well because the rodeo content largely focuses around system-level operations like provisioning virtual machines, creating Kubernetes clusters, interacting with those clusters, so on and so forth. Actions that are better done interactively instead of watching a video and trying to understand from just reading, something that's not interactive.
Yeah, I see. And what about other alternative solutions? Do you have competitors on this market at all? I haven't heard anything, but for sure you have some understanding of the market right now.
We do,
Yeah,
yes.
so
Go ahead, Chris.
Oh, I was just going to say yes. So we have, it's not necessarily as much a competitor as it is another alternative tool. Katacoda is going to be the name of the tool. It's kind of difficult to spell over here, but it is called Katacoda. And they were recently, I think, acquired by O'Reilly Media. So the important thing to note with HobbyFarm is that HobbyFarm is an open source project that was built to fill a need for Rancher. It isn't necessarily one that we are trying to go out to a market and try to get market share or anything like that. It's really just a project that we needed to fix a problem we had.
Thanks, guys. Thanks a lot for all the questions. But unfortunately, our time is coming to the end. And it was an awesome talk. And you've presented an awesome product. And I feel that it's needed. And I feel personally that I have a use case for it, so I hope everyone can find some for them. But if you do have any questions for our awesome speakers or even our expert, you are welcome to join the discussion zone in Zoom in the link below, or even ask a question in Telegram chat. So feel free, and guys, thank you once again for coming and speaking.
Thank you very much.
Yeah, thank you.
Yeah, thank you. It was a great talk.